Welcome back, class. We're looking at now question number 3 in the stats probability unit. Here's the prompt. For all probabilities, show work, round decimal answers to 3 decimal places and percent answers to 1 decimal. All right, so we've got a two-way table here, and here is the prompt. A bag contains 2 shapes, and each shape can be one of the 3 colors. The two-way table above shows the frequency of each shape. Now I noticed, class, I think your copy is going to be okay, but on my copy I have a typo, so I'm going to correct this. This number should actually be 16. So you can see this is a count of all the things in the bag. It tells me that there are 10 blue items that happen to be the shape of a circle, 3 blue items that happen to be the shape of a triangle, and so on. Here's our first question. What is the probability of randomly choosing a green shape? Well, the first thing I notice here is only one category is mentioned. And that means I know this is going to be marginal probability. I'll put the whole word right now. Marginal probability. So if I know it's marginal probability, I know that we're going to be using the grand total as the denominator. And the numerator is going to be all the items that are green. So I've got 9 green circles and 7 green triangles. That means I have a total of 16 green shapes. So my fraction is 16 divided by 35. Let's put that in the calculator. So 16 divided by, let's clear that. If I can get to clear. 16 divided by 35 equals 0.457. Take a look at the 1. That means that we're not going to round it up to 8 because the 1 is smaller than 5. It drops off. So all we have is 0.457. 0.457. And if we multiply that number times 100, let's go backspace, we're going to end up with our percent, which is 45.7. So 45.7%. From here on in, I'm not going to plug in the decimal, the fraction, or the decimal to get the percent. I'll just write the answers out for you unless I think I need to explain something with the calculator. All right, let's take a look at question number 2. I'm going to have to go back and forth between these questions, so I hope I don't give you guys a headache. What is the probability of randomly choosing a red shape and it is a circle? So I've got red and circle, and so you see here I have 2 categories mentioned. One is a column and one is a row. One column is mentioned and one row is mentioned. That means I know this is going to be joint probability. And for joint probability, we know again we're always going to use the grand total as the denominator. Let's count how many red circles I have. Red and circle. Here's red, here's circle. The intersection is 4. I've got 4 red circles. So we've got 4 out of 35. Your calculator should tell you the decimal is 0.114, and that's 11.4%. Next one. What is the probability of randomly choosing a blue or red shape? Blue or red? Well, blue and red are both, I think they're both columns. Blue and red are both columns, so 2 columns are mentioned with the word or in it. So when 2 columns are mentioned with the word or, I know that's going to be mutually exclusive because you never can have something show up in more than 1 column. So mutually exclusive. Now mutually exclusive also uses the grand total. All we got to do is figure out how many things are blue or red. Don't let the word shape throw you off. Shape just means doesn't matter what it is. It's not saying circle or triangle. These are all shapes in this bag. So blue or red? Well, we've got 13 blue shapes and we've got 6 red shapes. That means we have 19 total. And if you want to do the math here, just write 13 plus 6 equals 19. So I've got 19 divided by 35. Let's make that a little clearer. 19 divided by 35. And to put that in my calculator, I will get 0.543, and that's 54.3%. Next one. What's the probability of randomly choosing an item that is red or a triangle? Red or a triangle. Now take a look at this. We have one column, one row, and the word or. This means we have overlapping. And the reason why is because we know that a column and a row, they're going to have an intersection that we're going to double count. So red or triangle. So remember how we figured this out. We're going to figure out, let me change the color here. We're going to find the probability of picking red, and then we're going to add that to the probability of picking a triangle, and then we're going to subtract from that the probability of picking red and a triangle, and that's going to give us our total. All right, so let's take a look at that. Probability of picking red, it is 6 out of 35. So 6 out of 35. The probability of picking a triangle is 12. Here's 12 out of 35. So triangle is 12 out of 35. And then remember, class, we've got an overlap here. Some shapes in the bag are red and a triangle. So red and triangle, there are 2 of them that we have double counted. So we have to get rid of the double count by subtracting one of those groups, or 2 of those. You know, it's interesting. I'm looking at my notes. I wrote a 3 here. Why did I do that? Let me check and make sure I got that right. Yeah, red triangle is definitely 2. So let me verify again. Red is 6, triangle is 12, and red triangle is 2. All right, so my notes are incorrect. Let's solve this problem. 6 plus 12 is 18. 18 minus 2 is 16. So our probability is 16 divided by 35. Remember, we always use the grand total. The only type of probability we're not using grand total in is conditional. So I'm going to have to recalculate this. So 16... I can get the button to work. 16 divided by 35 equals 0.457. That looks familiar. No, I haven't done that yet. Okay, 0.457, 0.457, or 45.7%. Why does that sound so familiar? Let's take a look. Oh, we had that same probability for the marginal probability of a green shape. All right, let's continue. Assuming the item you select is green, what is the probability it's a circle? Well, there's that word assuming. I already know I'm going to be doing conditional probability, which tells me right away I'm not going to be using the grand total. Assuming you select green, what is the probability it is a circle? That means we're going to only be looking at the green column. Remember how we write this, class? The probability of a circle, if we do it backwards here, assuming it is green. So first we look at how many shapes are actually green. So here's our assuming column. It's got to be green. We got a total of 16 things that are green. That's going to be 16. And of the 16 things that are green, 9 of them are circles. So that means we got 9 circles out of all the greens, and that makes our fraction 9 divided by 16. Let's go ahead and divide that out. 9 divided by 16. Having trouble getting these buttons pushed. There we go. Is 0.562. We're going to round that to 0.563 because the 5 here rounds the 2 up to a 3. So 0.563. 0.563 or 56.3%. And then let's take a look at the last two. Next one, what is the probability of choosing a blue circle? So we're going to pick blue. We're going to return it, so put it back in the bag, and then choose a blue triangle. And I just realized we have to deal with the fact that we're picking a blue circle first. So I better make sure I look at blue circle. Pick a blue circle, return it, and then pick a blue triangle. Well, remember, class, in this case, you've got 2 trials. There are 2 trials. And that means we are going to be multiplying probabilities. Or multiply each probability. So let's do our first experiment, or our first event, our first trial, sorry. Pick a blue circle. Well, we've got how many blue circles? 10 blue circles out of 35. So our first probability is going to be 10 divided by 35. Now we're going to go ahead and put that back. We're going to reach in again. We've got the same probabilities now because we returned it. And now what's the probability of choosing a blue triangle? A blue triangle is 3 out of 35. So that's going to be 3 out of 35. And if you want the probability that both things are going to happen in a row, that means you multiply. So we're going to multiply these two things together. And we're going to get 30 divided by, we have to multiply 10 times 3 is 30. And remember, when you multiply, don't make the mistake, class, of just writing 35 here. That's if you add the fractions like we did up here. Take a look. When we're adding and subtracting fractions, the denominator has to be the same, and we don't ever change it. When you multiply, you actually have to multiply the denominators together. You're going to get a big number, 1,225. So don't forget, when you have multiple trials and you're trying to find the probability of those events happening in a row, you're going to be multiplying the numerators together, and you're going to be multiplying the denominators together. And now our fraction here is 30 divided by 1,225. That's a pretty small decimal, 0.024, which ends up being 2.4%. Not very likely that that's going to happen. The last one, if you choose 2 objects in a row and did not return either of them, did not return. And if it says 2 objects in a row, class, this is multiple trials. What's the probability they are both blue? So again, we're going to have 2 trials here. So I'm going to write here, there are 2 trials. And that means we are multiplying. I can spell that correctly. Multiply. Multiply your probabilities when you are trying to get something to happen more than one time in a row, or you are doing more than one thing in a row. Go back to this last one right here, this one where we're adding probabilities. Notice that we're only doing just one thing. We're randomly choosing an item, one item, and we're asking if it's this or this. That means we're only doing one trial. That's why we're adding the probabilities of each of those events and subtracting the overlap. Here, again, it's 2 trials. All right, so they're both going to be blue. So the first trial, what's the probability of picking a blue item? We've got 13 blue items out of 35. There's our first probability. 13 out of 35. Now let's think about this. We're not going to return the first thing we pick. That means we don't have 35 items anymore. We only have 34. And if the item we picked was blue and we want to pick another blue, that means we only have 12 blues left. So you have to assume in this trial you've already taken a blue out. we only have 12 blues left out of 34 total shapes. So there is your two probabilities. We're going to multiply these out. It's going to be 156. You multiply 13 times 12. And 35 times 34 is 1190. So our fraction is 156 divided by 1190. Divide that out. We're going to get 0.131 or 13.1%. Not a great probability, but much higher than the probability of picking a blue circle and then putting it back and picking a blue triangle. So there are hopefully good explanations for you regarding question number 3.